Today I am going to discuss about GC O-level physics. GC O-level physics, I want to summarize some chapter like chapter 1, unit physical quantities, and measurement techniques measurement techniques. First, introduce myself. I am Jahangir Alam. I am O-level and A-level physics teacher. My contact number is here. I did my BSc with first class from Russia University, MSc thesis group first class, and MPhil BUET from physics department. Today I am going to discuss some very fundamental basic thing. First, physical quantities. What is physical quantities? The things which we can measure in the physical world is called physical quantities. So remember, the things which we can measure in this physical world is called physical quantities. So the things which we can measure, or quantify by number, the things which we can measure in this physical world, is called physical quantity. Is called physical quantities. Remember, we can measure mass of an object, we can measure length of an object by number and unit. We can measure the temperature, we can measure the volume, we can measure the force applied on an object. So these are physical quantities. So example, physical quantity, example mass. We can measure mass, length, time. These are the example of physical quantities. So there are some non-physical quantities like emotion, love, affection. We cannot measure these things. That's why they are non-physical quantities. So all emotional quantities like love, affection, are the patriotism is the non-physical quantities. So physical quantities, types of physical quantities. Physical quantities. Types of physical quantities. According to the dependency, physical quantities are two types. One is fundamental or base quantity, another is derived quantities. So according to the dependency, so remember, according to the dependency, physical quantities are two types. physical quantities are two types. One is fundamental quantity, fundamental quantities. Another type is derived quantities. So according to the dependency, according to the dependency, physical quantities are two types. One is fundamental. The physical quantities which are neutral. The physical quantities which are neutral does not depend on other quantities, rather other quantities depend on them, is called fundamental quantity. So first, fundamental quantity. Fundamental quantities. The physical quantities which are neutral and does not depend on other quantity, rather other quantities depend on them, is called fundamental quantity. There are 7 fundamental quantity. There are 7 fundamental quantities. 7 fundamental quantities. Name of the physical quantities. Base SI unit. Symbol of unit. First, physical quantities like mass. Remember there are 7 fundamental quantity. First one, mass. Unit is kilogram. Full form kilogram, but in short form we use kg. Second, length. We use SI unit. SI, System of International. Unit is meter. Short form is small m. Short form is small m. And third one, time. Unit is second. Small s is the symbol. Now fourth one, temperature. SI unit is Kelvin. Kelvin is the SI unit of temperature, and short form is K. Number 5. Amount of current. Unit, SI unit is ampere. Short form capital A. Now number 6, amount of substance. We use mole. short form MOL, mole. And last one, luminous intensity, luminous intensity. We use candela. Candela is the unit of luminosity. Short form is CD. Short form is CD. These are the fundamental quantities. Look at this board. There are 7 fundamental quantities. 1960-তে একটা ইন্টারন্যাশনাল কনফারেন্সে ফ্রান্সে হয় এটা, সেখানে তারা ডিসাইড করে এই 7টাকে ফান্ডামেন্টাল কোয়ান্টিটি 7, there are 7 fundamental quantity, but truly fundamental quantity there are 4. Why these are truly fundamental? But amount of current, remember, amount of current means rate of flow of charge divided by time. So what is the meaning of fundamental quantity? Fundamental quantities are those quantities which are neutral, do not depend on other quantities, rather other quantities depend on them. So amount of current depends on charge and time. So why our scientists place as a fundamental quantity? At that time, amount of current considered as the base. That's why there is a problem here. So remember, we follow this chart. There are 7 fundamental quantities. Though current equal to rate of flow of charge, but we follow this. Amount of substance, mole. If we express a molecular mass into gram unit, then that amount is known as 1 mole. Like water, H2O, molecular mass is 18 gram. So 18 gram water means 1 mole water. 18 gram water. So 18 gram of water means 1 mole water. Remember, 18 gram of water equal to 1 mole water. So same as the mass. So but we follow this. Luminous intensity, the amount of energy, luminous intensity L is energy, amount of light energy passes through a cross-sectional area per unit time is called luminous intensity. So amount of light energy transfer per unit time per unit cross-sectional area is called luminous intensity. দেখো luminous intensity কিন্তু একটা কয়েকটা কোয়ান্টিটির উপর ডিপেন্ড করতেছে, কয়েকটা কোয়ান্টিটির, বাট দো আমরা এটাকে ফান্ডামেন্টাল কোয়ান্টিটি হিসাবে কনসিডার করতেছি। আসলে অনেক ফিজিক্স বা কেমিস্ট্রি বা সায়েন্সের অনেক জিনিস যেটা শুরুতে একটা জিনিস ধরা হয়েছিল সেটাকে আমরা ফলো করি, এটাকে বলে কনভেনশন, though it is wrong. So these are not truly fundamental quantity. These 3 are not truly fundamental quantity, but we follow this. Now derived quantities. The physical quantities which depend on other quantity and can be expressed by the power of multiple of other base quantities is called derived quantities. So the physical quantities which depends on other quantity, and these physical quantities can be expressed the power of multiple product of other quantities is called derived quantities. Like area. To measure area, we need to measure length, we need to measure breadth. Then by multiplying length into breadth, we get area. Volume. To measure volume, we have to multiply length breadth into height or thickness. So that's why area, volume is the derived quantities. Like speed equal to distance divided by time taken. Distance divided by time taken. Here distance, so speed depends on distance, that means length and time. That's why speed is a derived quantities. Speed is a derived quantity. So speed is a derived quantities. Like acceleration, look, acceleration depends, we know acceleration equal to change in velocity divided by time taken. Again velocity is a derived quantity, so displacement divided by time divided by another time taken, time. So we can write displacement divided by time square. So acceleration depends on displacement and time. That's why acceleration is a derived quantities. They are all derived quantities. So area is a derived quantities, volume is a derived quantities, speed, acceleration, all are derived quantities. Now unit of measurement. What is the unit of measurement? The essential amount of something is a standard essential amount is necessary, comparing with whom we can measure any physical quantities is called unit. So if we want to measure the length of this this rod, first we need a standard essential amount, comparing with whom we can measure any quantities like length, physical quantities like length. So first we need a standard essential amount, and comparing with whom we can quantify any physical quantities by number. That thing is known as unit. So unit is the standard essential amount. Comparing with whom we can measure any physical quantities. That amount is called unit of measurement. So unit of measurement has some characteristics. It should that means when we fixed any unit of measurement, that should be well defined. So it should be well defined. Number 2, it should not it should be reproducible. It should be reproducible. reproducible, should be reproducible. Now another thing, scalar and vector. According to the necessity of mentioning direction, physical quantities are two types. So there are two types physical quantities according to the necessity of direction. So the physical quantities which have only magnitude, no direction, is called physical quantity, are called scalar quantities. So the physical quantities which have only magnitude, no direction. So only magnitude, no direction is called scalar quantity. On the other hand, vector quantity, the physical quantities which have both magnitude and direction, and direction is called vector quantity. Is called vector quantity. Is called vector quantities. So give some example of scalar and vector. Scalar, like mass is a scalar quantity. Length is a scalar quantity. Length, time, temperature. Density is a scalar quantity. Work, energy. All type energy is a scalar quantity. Kinetic energy, gravitational potential energy, all are scalar quantity. Power related with energy and work, that's why power also scalar quantity. Related with current, like charge, current, voltage, EMF, resistance, all are scalar quantity. On the other hand, distance is a scalar quantity. Distance distance, speed, all are scalar quantity. On the other hand, weight is an example of vector quantity. Displacement has a specific direction. Displacement, weight, displacement. Then velocity is a vector quantity. Acceleration is a vector quantity. Remember, acceleration is a vector quantity because acceleration related with velocity. Rate of change of velocity is called acceleration. Momentum is a vector quantity. All type gravitational field all type field, gravitational field, magnetic field, remember, all type field, magnetic field, electric field, all are vector quantity. So gravitational field, magnetic field, electric field, all are vector quantity. Remember, the addition, subtraction, multiplication of scalar quantity follow the normal algebraic rule, but addition, subtraction, multiplication, division of vector does not follow normal algebraic rule. Here they follow spatial vector algebra or geometrical rule. To represent quantity, we use some prefix. Do you know? Say meter. Meter is the SI unit of length. So we use decameter. Short form is dm, means 10 to the power 1. 10 to the power 1. Hectometer, we use hm, 10 to the power 2. And now kilometer, short form is km, we use 10 to the power 3 meter. 10 to the power 3 meter. Kilo, then megameter, we short form is capital M, so mega means 10 to the power 6. Then giga, we use gigameter, say gigameter, capital G M, 10 to the power 9 meter, 10 to the power 9. So we use terameter, capital T M, 10 to the power 12 meter. Like same decimeter, dm, 10 to the power minus 1 meter. Centimeter, cm, 10 to the power minus 2 meter. Now millimeter, we use small m, so 10 to the power minus 3 meter. Then micro, we use this micrometer, we use mu symbol, 10 to the power minus 6. Then nanometer, 10 to the power minus 9 meter. 10 to the power minus 9 meter. Now picometer, pm, small pm, 10 to the power minus 12 meter. This is the suffix used mostly used in physics. You have to remember to calculate any quantity. So you have to remember this. You have to remember this. Okay, thank you watching my video. Please subscribe my channel and like and share my video if you think this video is helpful for your study. Then share this video with your friends. Thank you very much. Thank you. Stay with me.